particle, a new chapter. The second chapter is a kinematic of particles. But before that, just a brief review on lecture 6. I've already shared with you the recorded versions of lecture 6. So lecture 6 is actually concerned about the relative motion analysis. The last topic of chapter 2. You can watch the recorded versions or video at your own time. When you're free, at any time you're free, then you can watch that kind of video. When we talk about this relative motion analysis, actually there are two type of relative motions. First, we call it as dependent motions, and the second one is independent motions. You can also try to check it on the material that I've already shared with you in lecture 6, as well as the recorded versions or recorded video. And this one is a relative motion analysis of independent motions. There are three main equations when we talk about the relative motion analysis of independent motions. And the first one, we call it as a positions equations, which is RB is equal to RA plus RB with respect to A. And that is the first one. So that is the first equations, positions, positions equations. This one. The second one is VB is equal to VA plus VB with respect to A. The velocity equations. Where this velocity equation is obtained by taking time derivative of positions equation. So by taking time derivative of these position equations, we can obtain the second equation, which is called as the velocity equations. And the third equation is accelerations equations, where AB is equal to AA plus AB with respect to A, acceleration equations. And this equation is obtained by taking time derivative of velocity equation. So we have this velocity equations. We take time derivative of this velocity equation. Then at the end we got this third equation, which is acceleration equations of relative motion analysis. This one is considered as independent motions. This one. So this the two important equation is the equation 2 and 3, which normally we apply when you want to solve the problem which concern about this relative motion analysis. So they will ask you what is the relative motion analysis of what is the relative motions of particle B with respect to A. This means that you need to find out what is the VB with respect to A. What is the relative accelerations of particle B with respect to A, for example. So you need to find out what is AB with respect to A. And the second one is we call it as the relative motion analysis of independent motion. Motion analysis of dependent motions. Why we call it as dependent motion? Dia bergantungan pergerakan dia antara satu sama lain. Which is we have this block A and also block B. When block A move, look at these animations. When block A move downwards, block B will move upward. And block B move downwards, block A will move upward. The other way around. So in this case, for this dependent motion analysis for the relative motion, So we need to identify this two segment, which is called as the red one, which is SB, and also SA. We call it as SB, SA. We call it as changing segment. And for this A, B, and also C. So A, B, C is actually represented on this A, this one, length from this to this point. B is actually this chord which wrap around this pulley. This one is B. And C is chords which wrap around this pulley. And block B. This one is C. So this A, B, C is a constant segment. So when we deal with this kind of situations or problem for this dependent motions, what you need to do is you need to first, of course, you need to identify both of these changing segment and also constant segment. Once you identify all these kind of thing, the next step is you need to apply the also called the appropriate equation, which is called as a coordinate equations, position coordinate equation. And all of that is actually explains in detail in lecture 6, whether in what's so called in the lecture note and also in the recorded video that I've already shared with you this morning. You can watch that kind of video. So that is a concern about relative motions of dependent motions. And the new topic to discuss by today is, we call it as a kinetic of particle. We discussed about the applications of second Newton law of motions. General Newton law of motions, XY rectangular coordinate systems, normal tangent coordinate system, and radial transverse coordinate system. All of this actually the one that we have learned in what's so called chapter 2 as well. XY rectangular coordinates, normal tangent coordinate systems, R theta coordinate system. But in this case, we are applying the equation of sum of F is equal to ma, the second Newton law of motion. So how to apply this equation of F is equal to ma? Let's have a look on this Newton law of motions. Refreshing on this, what is the first law of motions? A particle originally at rest or moving in a straight line with a constant velocity will remain in this state provided the particle is not subjected to an unbalanced forces. So this one is actually concerned about the static, where in this case you need to apply this F, sum of F is equal to 0, equilibrium. If we consider on this XY planes, then we need to write it down as a sum of F x is equal to sum of Fx is equal to 0 as well for x axis. Sum of Fx is equal to 0 in the x-axis, and sum of Fy is equal to 0 as well for this equilibrium, which relate with this first Newton law of motions. Second law of motion is a particle act upon by an unbalanced force F experiences an acceleration A that has the same direction as the force and a magnitude that is directly proportional to the force. And this one is actually related with the sum of F is equal to ma, Newton law of motion, where sum of force is equal to mass times accelerations. See the one that this is the one that you are going to apply in this kinetic of a particle. And the third law of motion is the mutual forces of action and reaction between two particles are equal, opposite, and collinear. Okay, the next is concerned with relationship of force and accelerations. When a particle of mass m acts upon by a force F, the force and the accelerations A of particle must therefore satisfy the relations. So this actually represent on the application of the equation force is equal to mass times acceleration. If particle with a mass m, or if an object with a mass m is subjected to a series of forces, the directions, look at this one, and the directions of motions, particle follow the directions of the force. So look at these animations. Let's say we have this F1, force of 1, F1, let's say F1 is equal to 10 Newton, which is applied to this particle, the green circle represent on the particle that we consider. So the directions of motions follow the direction of the force. If the force direction of force is simply like this, so the motion will be to this direction as well, the same. Which in this case it will has an acceleration of a1. F1 we have an acceleration of a1. Let's say we consider that this particle has the mass of m, for example. Then it can be related directly with this equation of F is equal to ma. So F1 is equal to ma1. And let's say we have this F2, which move where a particle is acted upon by an external forces F2, it will have the direction as the force, which is it will have an acceleration of a2. Then we can write down the equation for this one is F2 is equal to ma2. And similarly, if we have this the third one, we have external force of F3, which is applied to a particle based on this direction. So this particle will has the motions, the direction of motion as follow the direction of the force itself. So which is we have F3 is equal to ma3. So the next is a simultaneous forces. So simultaneous forces actually concern about a force or related with a multiple forces which is acted upon a particle, a green one, a green circle represent a particle at the same time, simultaneously. So what will happen to this particle? Look at the direction of motions. If we have F1, it has the tendency to move to these directions, right? If this particle is acted upon by the F3, it will has the direction to this, and similarly to this F3, F2, it will move to these directions. So what is the actual direction for this particle? So look at the magnitude of this F1, F2, and also F3. Let's say F1 is equal to 10 Newton. F2, let's say F2 is equal to 15 Newton, right? And F3 is equal to 8 Newton force, which is applied to this particle. And it is applied simultaneously to that kind of object or physical body, whatever it is. So we can write down the equations of the resultant force, which is symbolized as F subscript R, F capital letter subscript R, which we call it as a resultant force. So this one is resultant forces. So Fr is equal to sum of Fq. So sum of Fr, actually, this Fr is equal to F1 plus F2 plus F3 is equal to Ma. Okay. Fr is the resultant force. The resultant force is equal to the combinations of F1 plus F2 plus F3, which is equal to M, mass of the particle, and A is the accelerations of the particle. So if this particle is applied with this multiple forces of F1, F2, and also F3, it will have the tendency to accelerate at E, as you can see here. So A is the accelerations, and the direction of acceleration, as you can see here, to the rightward at a specific directions. So that is the simultaneous forces which is applied to a particle. So the next is concerned about the applications of X-Y coordinate system. We know that the second Newton law of motion is F is equal to ma. So that is the basic what so called when we talk about the second Newton law of motions. Put your mind that it relates with the equation of F is equal to force is equal to ma. So if we want to apply this XY rectangular coordinate system, for example, so we have this block with this located on this inclined plane, as you can see here, with this applied with this multiple force of F1, F2, and Fn, for example. So this Fr, we want to apply this XY rectangular components. So we need to, of course, establish the axis of X and also Y as our reference. And what is the direction of motion? Let's say the positive sign for this X is to the leftward, to the rightward, and for this Y is to this direction, upward, at the specific direction, as you can see here. So Fr is equal to everything. We need to split it into the component of X and also Y respectively. Okay. So we're going to have the component of F1X, F1Y. So F1X, F1Y. Each of these, we need to break it down into the component of X and also Y. So F1X, F1Y. Similarly to this one. So we're going to have this F2X and also F2Y. And this one also. So kita akan ada this F3X and also F3Y. Kalau ada 3 komponen of external forces lah. Kalau lebih daripada itu, based on the number of forces or multiple forces which apply to this one. So all of this is Fr is equal to F1A, F1Y plus F2X plus F2Y plus blah 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 until Fnx, Fny is equal to M Ax Ay. So Ax Ay adalah based on this one lah. Kalau ni adalah Ax, Ay adalah in these directions. If we look at this one, if it concerned about a particle, or in this case a block which is located on a surface, on the ground, for example. So normally when we apply this kind of force, see Ay is equal to 0. So the only thing that we need to consider is Ax on this one. And for this one, we can write down the equations, as you can see here, and simply write down the equation of sum of f x is equal to max in these directions. Sum of fy is equal to may upward. This one is our positive sign conventions. So it depends on the direction or motion of this particle or object or physical body. If it moves to the leftward, we can use the positive sign conventions simply like this. Let's say this one is x, then we need adalah y. If we have this kind of block which is located on this surface, and we pull this block, this is P is the external force, we pull this block, is of course it will have the tendency to move to the leftward and at an acceleration of e. Then we can use the positive sign conventions of x and y, x positive to the leftward and y upward, something like this. So this is our positive sign convention or our reference. It's not exactly everything need to be positive to the rightward. It depends on our reference or our positive sign convention that we put or that we set on that kind of method of solutions or analysis. So kalau kamu lihat kat sini, Earth system trajectory x horizontal and also y vertical. Untuk x tu dia punya sum of f, x is equal to 0, but sum of fy is equal to negative mg. It's related with the trajectory that you learned in chapter 2. So the next is normal tangent coordinate systems. So if we have this kind of situations where a particle moves according to circular path of motions, then we want to apply this normal tangent coordinate systems. So we need to consider on this f sum of ft and also f sum of fn, or we can also write down the sum of fn for this one, and this one is sum of ft is equal to mat for this one and man for this one, and therefore we can write down the equation for this normal tangent for this Newton law of motion. Sum of f t is equal to mat, and we know that sum of ft is equal to at itself is equal to r alpha, and for the normal directions, sum of fn is equal to m a normal for this one, and we know that an itself is equal to, we can use this v square divided by r, or we can use this m multiplied with r omega square, as you can see here, this one. So you can use either one of these equation, whether this one or this one, it depends. Let's say they give you in form of this data in the problem or questions, then we can use, let's say the velocity is given and also the radius of curvature is given, then we can use, or we can apply directly using this equation. If they give you in form of this angular velocity, which is omega, then we can apply this equation. So the next is radial transverse coordinate systems. R adalah radial and theta is transverse. Radial transverse coordinate systems, let's say we have a situation where we want to apply this radial transverse coordinate system, which in this case a particle move according to curvilinear path of motion or circular path of motions. As you can see here, then we can write it down the equation of sum of f theta is equal to ma theta, and also for this one sum of f radial is equal to ma r, and we know that a theta and also a r itself is equal to, this one is a theta, this one is a radial accelerations, and a theta is the transverse acceleration. So radial acceleration is equal to r double dot minus r omega square, while transverse acceleration is equal to r alpha. So alpha is an angular accelerations, angular accelerations. R alpha plus 2 r dot omega dot, 2 r dot omega, sorry. R a theta is equal to r alpha plus 2 r dot omega, ataupun is r alpha plus 2 r dot theta dot. Also we can, it's possible to be written simply like this, or r alpha is equal to r theta double dot plus 2 r dot theta dot. So we can also use this equation as well. So r theta double dot is actually equivalent to alpha. Theta double dot is equal to alpha. Theta dot is equal to omega. Omega dot is equal to alpha. Omega dot. Because you need to familiarize with this symbol and also abbreviations when we deal with this kind of radial transverse coordinate system. So the next is concerned about forces to consider. So there are several forces which need to be considered when we want to do the analysis which concern about kinetic of a particle. So here is the list of forces which need to be considered. As you can see, the first one we call it as external forces. External forces. Let's say we have these situations. A block which is located on this surface, on the ground, for example, and external force of P which is applied to this block. So due to the action of these external forces, this block will move to the rightward and a specific direction of motion. It will displace from position from 1, let's say from 1 is the initial, to 2, from the initial to the final positions. So it will displace to the rightward, and accelerations of A and also the velocity of B. So the P itself, we call it as external forces. These forces are purely given from external to the body, resulting in body motion. So this body or this block will move to the rightward due to the action of this external force P. The next is force generated by motions. A moving body may influence another body to move, especially when there is relationships between them. So we're going to have a look on the example of this force which is generated by motions. Let's say we drive a car, we travel through what's so called circular paths or motions or circular roads, for example. So we're going to have the force generated by motion. We call it as a normal force will be generated due to the rotational motions of a car which will drive. So the third one is a force generated by gravity. An object with a mass and under influence of Earth's gravitational system must undergo internal forces, which is called as weight. Yeah? So let's get back to these illustrations. So let's say we have this block with the mass of m. Of course, this block itself has force which is generated by gravity. We call it as weight, W. So in this case, W is always directed downward, and W is equal to mass multiplied with gravitational acceleration of G is equal to 9.81. So G is always directed downward. So each physical body or object will have a specific mass, and if it has mass, then of course it has weight or the internal force. We call it as a weight for this internal force. Force generated by touching surface. When an object touch another, a normal force will be generated perpendicular to the surface. We're going to have a look on the next pages regarding this force generated by touching surface. And the last force, we call it as a force generated by frictions. We can simply call it as a frictional force. When an object moves, a friction force generated due to the rough surface. It could be solid or fluid surface. So it depends on the type of surface itself. And we consider on this illustration of this block, which is located on this surface, a rough surface, then if we apply the force of P, it will have the tendency to move to the rightward, and at the same time, it will have a frictional force of this one, let's say Fr. Fr represent of frictional force. Normal force dia macam ni direction dia. This one is N. It is always perpendicular with this surface itself or this normal force. Here with the animations, the illustrations of external force which is applied to this object. And due to the action of this force, this guy fall down, as you can see here. And the next is force generated by motions. So this blue car move or travel based on this curve within a path of motion. So at this instance shows it will have force which is generated by motion. We call it as a Fn. Fn is the normal force which is directed toward this center of curvature O. This instance shows. And other type of force generated by motion is we can relate with the relative motion analysis of dependent motions between block and also pulley system. So the next is a force generated by gravity. So we have this kind of illustrations. A block, a green block which is located on inclined plane, the first one, and the second one is a block which is located on a flat surface, horizontal plane. So look at this W. W is weight, force generated by gravity for this one. Word of this. And if you look at this vector of weight, it is directed downward vertically. The force due to gravity always in vertical directions. Vertical direction. Bukan horizontal direction. Force generated by gravity. It is always directed downward. Remember that? For W, it is always directed downward vertically. In whatever situation, situation of the plane itself, whether it is horizontal plane or inclined plane, it will always directed downward for this W lah. So the next is force generated by touching surface. So we have this block, rectangular block, and also we have spherical block, green one. Look at N itself. So N is the normal force. N adalah normal force. So look at these illustrations. Normal force always perpendicular with the surface of the object. Okay, remember that? Normal force always perpendicular with surface of the object. So kalau surface dia macam ni, on an inclined plane, so it will always perpendicular ataupun bersudut tepat dengan permukaan tersebut. Kalau dia rata-rata lah, kalau dia sengit, maka dia akan sengit lah dia punya normal force. So the next is concerned about force generated by frictions. So let's say we have a block which is located on an inclined plane. An external force of P we apply to this block, and due to the action of this force P, it will move to the rightward based on this inclined plane. It will has an acceleration of A. P is the external force. A adalah acceleration. F adalah frictional force. So this graph is actually represent on friction force versus external force of P. So when F is equal to P, no sliding occur. So makna dia bila kita kenakan suatu tindakan daya kepada suatu jasad, sama ada berada dalam kedudukan sending, sengit ataupun permukaan yang tidak rata, tidak bersifat horizontal ataupun mendatar, sebagai contoh, kan? So F, the frictional force, is equal to P. As long as daya tersebut tidak melebihi F itu tidak, P itu tidak melebihi F lah. When F is equal to P, when F just before it slide, so F is equal to mu S multiply with R. R is the normal force. Normal force. R adalah normal force. Which means that we can put here this as R, normal force. So F is equal to mu SA, mu SR. Mu S is the coefficient of static friction. Mu S is equal to coefficients of static frictions. Kalau mu R adalah sorry. Kalau R is equal to, in this case, normal force. R is the normal force. So F is equal to mu SR just before it slide. When it slide, then we can apply, we can use this F is equal to mu KR. Mu KR adalah mu K is equal to coefficients of kinetic friction. Coefficient of kinetic friction for this mu K. So bila dia dah start slide ataupun bergerak, maka we need to apply the equation of force is equal to, the frictional force is equal to the coefficients of kinetic friction multiplied with force F. Okay, F is equal to mu KR for this one. And this one is the combine all forces. Combine all forces. Let's say we have a vehicle which move according to this inclined plane and move according to, let's say, circular path of motions. So this vehicle will have the forces, as you can see here. We have this W represent on weight. N1, N2 adalah normal force. F2 ni adalah frictional forces. F2 adalah friction force. Fn adalah force of moving particle. F2 dan juga F1 lah. F2 dan juga F1 adalah rujuk kepada frictional force. Itu adalah combine of all forces. Let's have a look on this check for understanding. So the first question is determine the accelerations which result when a 12 Newton net force is applied to a 3 kilogram object A and then a 6 kilogram object B. So the keyword is apply the basic equations of second Newton law of motions, which is sum of F is equal to ME. Okay, basic equation of F is equal to MA. Let's have a look on the first one. Determine the accelerations which result when a 12 Newton net force is applied to a 3 kilogram object A and then a 6 kilogram object B. So ini adalah objek A. Result when a 12 Newton net force is applied. Okay, A 12 Newton. And then 6 kilogram objek B. Ini objek B. Objek B, objek B. Determine the accelerations which result when 12 Newton net force is applied to 6 kilogram objek B. Yang ini adalah 6 kilogram. Yang A adalah 3 kilogram. So to solve this one, mudah je Guna persamaan asas which is F is equal to MA. Yeah. It is given that determine the acceleration will result when 12 Newton. F adalah 12, M 3 kilogram dia, M 3 kilogram, 12, okay, MA. So in this case, A is equal to 12 bagi 3, 3 kali 4. 4 meter per second square. Okay. Determine accelerations. So unit tu kena tengok betul-betul lah. Kalau accelerations, unit dia adalah meter per second kuasa 2. Okay. Kalau mass ataupun weight, mass dia adalah 6 kg, then you just substitute to these equations. This one is for this 3 kg adalah yang ni lah. In this case, A is equal to 4 kali 3, 12. Okay. Kalau 6 kg, 12 is equal to 6A. Jadi A sama dengan 2. Okay, 12 is equal to 6 kali dengan A. A is equal to 12 bagi 6, 2. 2 meter per second square. And the same goes to example 2. Check for understanding, which is a net force of 15 Newton is exerted on an encyclopedia to cause it to accelerate at the rate of 5 meter per second square. Determine the mass of the encyclopedia. Okay. Yang ni pun consider sebagai straightforward punya question lah. Straightforward punya questions. We can just substitute into the equation of F is equal to MA, then you can get the answer from that. Okay, I give you the answer for the third one. The third one is suppose that the sled is accelerating at a rate of 2 meters per second square. If the net force is triple and the mass is double, then what is the new accelerations of the sled? So the answer is number 3, 3 meters per second square. And for question 4, suppose that the sled is accelerating at a rate of 2 meters per second square. If the net force is a triple and mass is half, then what is the new accelerations of the sled? Which in this case, the answer is 12 meters per second square. Okay, you can try to do it at home. Try to do it at home. Then, if you have any problem, then you can ask me later. Let's have a look on this example 1. Example 1, given that a 50 kilogram crate rests on a horizontal plane, the coefficients of kinetic frictions, mu k is equal to 0.3. The crate is subjected to a 400 Newton towing force, which is this one, as you can see here, these illustrations of this crate. This pull with the constant force of 400 Newton and the directions of 30 degrees. So the question is determine the velocity of the crate in 3 seconds. And the second one is what is the distance of the crate in 3 seconds. Let's continue with the one before that I want to add a blank slide. show you on the method of solution for this one. So solutions, example 1. So the first step is you need to draw the free body diagram. Okay, draw the free body diagram. So we have a crate which is located on the surface. So we have this external force of E, which is equal to 400 Newton, and the angle between this is equal to 30 degrees. And we have this kind of situations. So we need to break it down into the component of X and also Y. So this is X, Y is our positive centering measurements of this analysis. So it will has the tendency to accelerate at an acceleration of A, and the velocity of V in this case to the right one. So we need to consider also it gives you the mass of the crate, which is equal to 50 kilogram. So W is equal to mg, m is equal to 50 multiplied with 9.81, and is equivalent to 490.5 Newton. So instead of this internal force, the other forces which need to consider is the normal force of NA. Normal force of NA. And also we have a frictional force which need to be considered, which is F is equal to mu K and A. F is equal to mu K and A. So that is the first step. The first step is you need to draw all forces which act on a particle at this instant shown. And after that is hilang solution so you continue on this. FBD. So FBD we have the crate simply like this. So W is equal to 490.5. And we have the component of okay, this one is P, which is the 400 Newton. So we split the component of X and also Y. So this one is 400. This one is 30 degree. Cos 30 degree. So we have this what's it called the component of x and also y. So our positive sine conversion of x, y. So kita ada komponen 400 cos 30 degree and also this one is 400 sine 30 degree. And don't forget about the normal force of N and A. And also the frictional force of F is equal to which in this case the also called the frictional force. The coefficient of what is the coefficient of kinetic frictions? 0.3 so we can put in this 0.3 and A. So here's the also called the free body diagrams of this example 1. So the next step is once you draw the free body diagram showing all forces which act on the particle or this physical body. The next step is applying the equations of motions. Apply equations of motions. So sum of F X is equal to MAX. Go right. So 400 cos 30 degree minus mu k and A fifty A X equal to A so let's consider this as the first equation, equation 1. So if you look at this one, we can substitute directly. This 400 cos 30 degree minus mu k is equal to 0.3 and A is equal to 50 AX. Let's consider as one. So if you look at these equations, we have two unknown which is NA and also A subscript X. And therefore, we cannot solve this problem. We cannot solve this problem. Let's consider on the y directions. Sum of Fy is equal to MAY. So NA plus 400 sine 30 degree minus 490 0.5 is equal to 50A, which in this case A is equal to 0. You can so we only have one unknown, which is NA, and therefore 290.5 Newton. Okay, equation number 2 for this y directions. Equation number 1 is for the x directions. So we have the answer for this normal force. If you look at the first equations, we have two unknown, which is A, X, and also NA. Then we can substitute equation 2 into 1. The 2 substitute into 1, we can obtain this A subscript X. Two. Two. So 400 cos so in this case, when we apply the what so-called these equations, we can directly obtain the angular accelerations of A, which is equal to 5.19 meter per second square. So they ask you also to find out what is the velocity or the speed of this what so-called these blocks crate in 3 seconds, right? So in this case, when you want to solve this velocity, the third step is find velocity. At t is equal to 3 seconds. 3 seconds. So we need to apply constant accelerations. Apply constant accelerations equations, which is v is equal to v naught plus at. So v is equal to v naught is equal to 0 plus 5.19 multiply with 3 in 3 seconds, and we can get the velocity of v, which is equal to 15.6. Okay, v is equal to 15.6 meter per second. So that is the method of solution for example 1. Is there any questions before we dismiss?
No, sir.
Okay, I want you to try to. Here is the example of the method of solution as well. And refer to this one as well. So we need to apply this. The first step is we need to draw the free body diagram, and then we apply the equation of motions, which is sum of F is equal to ma. And the third one is we need to apply the kinematic equation of motions. And in order to obtain the the velocity of this crate at 3 seconds. And what is the distance s? By applying the constant acceleration equation, let's say you apply this v square is equal to v naught square plus 2a bracket s minus s naught, then we can obtain the distance of s. You can try to do it as well. And here is another one. This one is problem 1. You can try to do it at home. The answer here is T is equal to 5.60 kilonewton. The question is the crane lift a crate of mass m with an initial acceleration a, where in this case acceleration is equal to 3 meter per second square upward. When this crane lift a crate, it has an acceleration of 3 meter per second square, which means the force in each of the supporting cables due to these motions. So you need to find out what is force on each supporting cables. You can try to do it at home as well. If you have any problem, then you can ask me later on. So instead of this problem 1, we have also the example 2. We'll continue by next week, inshallah, for this solution of this example 2 before we continue with the next topic of work and energy. Okay, class, any questions regarding this topic? Okay, tak ada eh? If there is no question, then I think we dismiss. And see you again by next week. Next week is the mid-semester break. Next 2 weeks, after mid-semester break, we will what's so called, we will meet face to face.